Hey there YouTube, Superbrain AK here. Check it out. I got the power supply mostly wired up. I got 2 out of 3 of these outputs. I have, whoops, try not to blind you. 1, 2, 3, 4. These 2 are in series, and then these 2 are in series. So they've got this diode arrangement here. See that there? So those are LM2596 diodes there. And then I've got another 2 diodes there. And that goes to the 2 XT60 outputs. So yeah, that's pretty cool. And also I've got a piece of metal on the bottom, which makes about a 1mm clearance underneath, so that way air can possibly go underneath them. And it also keeps it even because there's motherboard standoffs underneath it. So that side, that was already bent from the piece that I cut, so I just bent it in, made it perfect. But I did have to pull that piece out. There was a little indentation. But yeah, you can see I've got the fan spinning, and got that connected up here on the alligator clips, going over to here, which is an LM2596. That's reading the voltage there, 3.88. I've got a temperature reading going here. So what's going on with this? So there's, follow this wire up. We've got about 18 volts there. And so that's what's powering this. And then, so this is an LM2596 board, which I pulled out the 143. There you go, 103. So that's a 10K pot, and replaced it with a 100K pot. So I did leave the resistor here, which pulls that pin to ground. That's the negative tab there. I did change it out for a 500 ohm instead of a 330. Just, I don't know, increase resistance, maybe make it more sensitive. But I've got this transistor here from the output, and then this is going to a 10K thermistor inside a little package that I made. Took some Kapton tape and taped the thermocouple, my thermometer, and the thermistor, and wrapped it in some insulation across a 4 ohm resistor. So that way I can increase the temperature without, while being pretty accurate. So you can see this circuit there on the breadboard. I've got this going to a B550 PNP transistor. I think that's right. And then the thermistor comes from the positive output. That's its 3.9 volts right now, and goes to its base. It's emitter base collector, and the base is in the middle. So that's pulling this up, and then this is going over to the 100K potentiometer, which is about 50K right now. I believe that's how I had it before. I've done a little bit of tweaking since then, but so that brings it low, which would turn it on. And I believe resistance decreases as it heats up. Resistance decreases, causing the higher voltage there, turning off the transistor actually. Yeah, anyway. That's how it's wired up. The collector goes to that there and there. Right. That's actually right, because the more voltage that goes to the sense wire, the lower the voltage on the output would be. So right now, as this is warm, or as it's cold, 25C, the voltage is low. As it lowers its resistance, less voltage will be coming out of this transistor, and so it's going to need more voltage to overcome it, because this has to be a constant 1.25 volts on that pin. So it's going to make this resistance, or this voltage, whatever it needs to make that the right voltage. So anyway, let's put a little power in that resistor. Yeah. Let's let it cook up a little bit quickly. You can see the other one is a bit more sensitive. The fan ramping up. I'm probably going to overshoot. Yep, there's 71. Yeah, it was a little bit too much. But yeah, I think my goal was to have it 12 volts at AAC, so it's pretty close there. Warming back up. So yeah, this thing's definitely going to cool itself off. You can hear how loud that is. That's moving a fair bit of air. Yeah, let's put you behind it. Yeah, there we go. So it is able to overshoot 12 volts. Since it's being fed by 18, so this can go up to 18. If somehow the voltage isn't able to, it's not able to achieve that resistance. But for the most part, you can see it stays under as long as it's under 80 degrees Celsius. So yeah. I guess that's it. Just a quick battery update. Got that meter there saying 1299. Battery I took out because it's now recharging. 480 milliamps on this guy, which this does terminate at 10 or 11 milliamps, so that's actually pretty useful. And you can see I'm on the third unit there. I know the first one I tested 6 times. That wasn't necessary, but I had to get a baseline to see what things were doing. And it seems like LifePo 4, this is what that cell is, just because it's more accurate. After being not used for quite a while, doing 6 discharges gains 20 milliamp hours. Not bad, almost 30. It's getting there. But I think this unit might be a little bit high. I'm not sure. But so far that's unit 3. So I've got one more discharge on this guy. And then I've got 3 left to do. Those are the other first 2. So yeah. Thanks for watching. Hope you enjoyed. That's a little fan circuit. I know the LM2596 is a bit overkill for just this circuit, but hey, it works pretty well. So, thanks for watching. Stay tuned for more.